So, continuing on with derivatives, for today we'll talk about the trig functions and their derivatives. So we saw in terms of trigonometry class that we looked in terms of sine, cosine, tangent, cosecant, secant, and cotangent. And so remember, in terms of our basic sine wave, the sine wave looked like that. And that was my basic sine curve. And then we said in terms of sine, you could take the sine of any angle, and the results were numbers from -1 to positive. Okay? And so we had in terms of inverse sine, which is what you use when you wanted to find out the angle. Okay? So if I wanted the inverse sine of 0.5, well, it ends up that actually occurs at two places here. It would occur in both the first quadrant and in the second quadrant. Okay? But again, on your calculator, if you mentioned in trig class, your calculator is really only set up to give you answers that come out of either the first or the fourth quadrant. So we had, in terms of trig class, our basic graphs of these functions and how they worked. Right? And in terms of the trig functions, we had the basic three. Again, were sine, cosine, and tangent. And tangent itself actually can be rewritten in terms of sine and cosine. As I remember, in terms of the whole SOHCAHTOA, we said that tangent was opposite over adjacent. That's what tangent is. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And so if I look in terms of this compound fraction, we have opposite over hypotenuse divided by adjacent over hypotenuse. And the way you divide fractions is to leave the first one the way it was, change the sign to multiplication, and flip the second one over. And so we got that this would go away, and we're left with tangent being opposite over adjacent. And so given that everything can be rewritten in terms of sine and cosine, that'll become in handy when we talk about the derivatives of these various trig functions. So the first trig function, the basic trig function, is sine. So if we have y equals sine x, and I want the derivative of sine, the derivative of sine is cosine. So the derivative of sine is cosine, and then in terms of cosine, my derivative of cosine is given to be negative sine. I know these are the two basic two, and out of all the trig functions, the only ones you really should remember are these two. Otherwise, you have a table which you'll have access to that has what these are. But those two, you should be able to remember what they are. Right? So for example then, let's say we want to find a derivative of a sine function. So let's say we have y equals 2 sine 3x. Right? Well, in terms of this, a more formal definition as to my derivative of sine over this, that d dx of sine u, whatever that may be, is given by cosine, and then we'll talk about what all this means here in terms of this particular problem. Right? So really what all this says, really to do, is that my derivative of this y prime is going to be the 2. Derivative of sine is cosine. The angle stays the way it was. But then because now I need to take the derivative of this angle, and the derivative of 3x is going to be 3. And so now we can combine and simplify this a little bit, and we get 6 cosine of 3x. And that'll be my derivative. Right? So we definitely, the way it works is you change from sine to cosine, the angle stays the way it was, and then you take the derivative of the angle, and we get our derivative. Right? The same thing would be true in terms of our cosine function. So if we had y equals 4 cosine, right, cosine 8x, and we want to take the derivative of that, so my derivative, y prime, the 4 comes down. Derivative of cosine is negative sine, so let's put the negative out front, and then we get our sine. The angle stays the way it was, which was 8x. And then we take the derivative of the angle, which was 8. And so again, we can combine and simplify a little bit, and we end up with this being my derivative. And again, derivative is a rate of change on the curve. So in terms of all the various trig functions then, we got sine and cosine. The other one that is tangent. So let's look in terms of what happens with tangent. And we'll look at just the basic tangent function, tan x. But tangent, we said, can be rewritten in terms of sine over cosine. So if I look at this and I think back in terms of my quotient rule, we got that f will be sine x, g will be cosine x. The derivative of sine is cosine, and the derivative of cosine is negative sine. So now if I take those and put them all into what happened with the quotient rule, so my quotient rule says start with the bottom one first, times the derivative of the top, which is also cosine, minus sine x times a minus sine x all over the bottom term squared. So we get this, right? Well, we can simplify this a bit, because after all, this becomes a minus of minus. So this is cosine squared x plus sine squared x over cosine squared x. Now it ends up in, there are things called trig identities, and one of those identities is that cosine squared plus sine squared is equal to 1. So this will become 1 over cosine squared. And so we said in terms of the trig functions that secant was the reciprocal of cosine, and so this will become secant squared x for my derivative. Okay? So we got our derivative of tangent function. So in terms of all the derivatives of all the 6 trig functions, have a table we will put in that has them all on there. And so this is my list of derivatives for all 6 of my trig functions. Right? Again, derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared, the derivative of secant is secant and tangent, and cosecant is negative, cosecant, cotangent, and then cotangent is cosecant squared. So basically with this in front of you, you ought to be able to come up with the derivative of the various trig functions. Right? So for example then, let's say I had something like this. So given y equals secant of 4x, I want to know what is the derivative of that. Okay. Again, based on that chart we just had, we got that the derivative of secant is secant u tan u. So this is going to be secant 4x, tangent 4x, and then we have to take the derivative of the angle, which was 4x, and so that is 4. But then, in terms of convention, we'll take that 4 and bring it to the front, and we end up that my derivative is given by the. So that would be my derivative of this particular y. So let's look at another example. Let's say now we got something like this. Y equals 8x squared 2x times the tangent of 5x squared. Okay? Well, I think in terms of my basic rules from the last time, we got, well, this is prodigal. So let's call the first part the f, 8x squared plus 2x. We'll call this back part the g, tangent of 5x squared. We take the derivative of the front piece, which will be 16x plus 2. And if we take the derivative of the back piece, we just said that tangent became secant squared. So this is secant squared of, and then the derivative of the angle in this case is 10x, and so we'll rewrite this as 10x So now that we have all the pieces, we can now plug that into our format for the prodigal. So y prime will be 8x squared plus 2x times 10x secant 5x squared plus 16x plus 2 times tangent of 5x squared. And that will give us our derivative. So all the same rules apply that we had before in terms of product rule, quotient rule, and even in terms of the power rule. So let's look in terms of something like that. So let's say y equals sine cubed of 2x. Right? And I want my derivative. Well, we said, well, the 3 comes out front. Drop the exponent by 1. The angle stays the way it was. Right? Get that. Then we take the derivative of this, and the derivative of sine is cosine. And then we take the derivative of the angle, which was 2. So we end up with all this, and then this can be simplified. We could take this 3, combine it with that 2, and we get 6 sine squared 2x cosine of 2x. And that would be my derivative in that case. Right? After all, you could think of this in terms of being also written this way. Right? And so again, the rule was to take this out front, which we did. Keep everything the way it was and drop the exponent by 1, which we did. And then you take the derivative of what was inside, and so the derivative of sine is cosine. The angle stays where it was, and then take the derivative of that angle, and we end up with sine. So let's look in terms of another example. Let's say we got y equals x squared square root tangent 2x. Yeah. So first off, we got to get rid of the radical, and so this becomes tangent of 2x to the 1/2 power. Okay. But think of it that way. Again, generally, in terms of trig functions, when you have them raised to a power, the power will be moved inside. Otherwise, you have to do like I did with the parentheses and brackets. Right? But again, now this is product rule. So we got f is x squared. G is going to be tangent 1/2 2x. My derivative of x squared is 2x. My derivative of this will be 1/2 tangent. Now to the minus 1/2, again you drop the power by 1. So 1/2 minus 1 is minus 1/2. And then my derivative of tangent will be secant squared 2x. And the derivative of the angle is 2. And now if we combine and simplify a bit, we get that 2 times 1/2 is 1. So we get tangent to the minus 1/2 of 2x secant squared of 2x. Okay? And then again, we could take all the pieces and plug them into that format in terms of my product rule. So we get x squared tangent 2x secant squared 2x plus 2x tangent minus 1/2. And that would be my derivative. Right? So again, in terms of our trig functions, we can find our derivative. We can also find tangent lines like we did before. So let's look at one of those, for example. So let's say I want to find the equation of the tangent line to sine squared x at x equals pi over 3. Okay? So we're going to find the equation of the tangent line. Now, generally, and again, in terms of trig and calculus, things are going to be done in terms of radians. So I need to know what is the derivative of sine squared x. So my derivative, y prime, will be 2 sine x. Okay? Again, the 2 comes out front. We drop the exponent by 1. And then the derivative of sine is cosine. Okay? Now, because we have a point, x is pi over 3, we can evaluate this. So this is going to be 2 sine pi over 3 cosine of pi over 3. Right? And so we can evaluate that and get our value here. So pi over 3 is also 60 degrees, and so this is going to be 2. This is going to be the square root of 3 over 2. Cosine will be 1/2. So we can multiply all these out. And we're going to end up here with the square root of 3 over 2. And that will give us our value. Okay. So that would represent our value of the slope. Okay. Well, we also know the x value. We know x is pi over 3. Okay. So what we need to know now is what is the corresponding y value. We got y equals sine squared of x. So y is going to equal the sine of pi over 3, that number squared. Now, the sine of pi over 3 is the square root of 3 over 2. And then if we square that, well, if you square a square root, you just get what's inside. So this is going to be 3/4. So we know the x, we know the y, we also know the slope. So if we go back to our equation of a line, y minus y1 equals mx minus x1, we can get our values. So we got y minus my y1, which we said is going to be 3/4. My slope, which is the square root of 3 over 2, x minus pi over 3. And that would be the equation of the tangent line at that particular value. And everybody should be able to take that and actually rearrange it if we wanted it to into the corresponding point slope form. So we had in terms of the derivatives of my trig functions, and again, you should be able to find the derivatives given that you're going to have that chart. Okay? And being able to plug in and find the derivatives of the trig functions given that you have that information with you. Okay? And that will conclude this lesson.